Hi, I want to share another video on irreducibly complex. Remember, an irreducibly complex system is one where all the parts have to be present in order for anything to work. If one particular thing is missing, then the thing won't work. Remember the example we used in the last video, I think it was video 11, we had an example of a mouse trap. And you have to have the hammer, you got to have the spring, you got to have the board to hook all the stuff together, you got to have the catch, you have to have 6 or 7 different things. And if you don't have even just one of them, the whole thing doesn't work. It has no survival value. And so the idea here is that there are some systems in living organisms that appear to be so complex that they could never happen by chance because all of the things have to happen at once. And remember, according to uh, evolutionary theory, according to a materialistic type of approach that Darwin used, basically, you can't. You have to have all the systems in place in order to have survival value. If you don't have survival value, then the things can't be passed on to their offspring. And according to evolution, this happens in small little steps, not great big giant jumps where you have like 20 mutations all at once. Let's give you a couple of examples here that we can talk about. So let's talk about this one, honeybees. I don't know how much you know about bees, but honeybees have an amazing way of communicating to each other. This has been discussed for years and years and years about how complex the system really is. If a bee comes back to the hive and he has found some food, what he wants to do is share that with all of his fellow bees. And so what he does is he kind of comes back and he does this little dance, and he does a little dance in kind of a circle. And basically, what he's doing is he's telling the bees that if they just go out and they just look really close to the hive, they can just go circle the hive, and there's some food that's really, really close. And when I say close, we're talking just a few feet or so. And he does this little dance, then the bees look at that and they say, "Oh, okay, there's some food really close," and they take off and look at it. Now, how do they know that? You know, well, they know this by instinct. Nobody teaches them to dance. This guy doesn't teach them to dance either. Not only that, if the length of the waggle is different, okay, what he does sometimes is instead of just going in a circle, what he'll do is he'll go and then he'll cut across the circle and kind of wiggle his butt. They call that a waggle dance. And depending on how many times he waggles, that tells the bees how far away the food actually is. So not only can he tell them that it's close, but he can actually tell them that it's far away, and he can tell them exactly how far away. And he comes in and does these dance, and then they look at that and they say, "Oh, okay," and they go right to it. But not only that, he also goes at a particular angle on the hive, okay? And that angle, it tells them where the food source is, and it's basically in relationship to the position of the sun. So if the sun was up here like this, 90 degrees, then this would be 90 degrees. So if he's saying this would be 0 where the sun is. So if he was going this direction, that would be 90 degrees from the sun towards the right. Okay, that would be the west, I think. Anyways, what would happen is he would go and they would all know which direction to go. Now, this is pretty amazing. I mean, think about this just by how he dances. But now think about how could this actually happen by chance? I mean, let's say, Joe B comes back to the hive and somehow he's inherited this mutation where he can communicate by his dance. And he knows, like, if he does this particular waggle and he goes across, and then he comes back here and he does the waggle again, and he's doing it in a particular direction, that would be telling the people how far away it was and also what direction it is. But remember, if he's the only one that inherited this gene, he would be doing this and everybody else would be looking at him and say, "Hey, Joe, what's going on? What are you doing? You've been, blowing smoke or what? What are you on drugs? Why is he dancing like that? What does that mean?" You see, not only does he have to know this and know the direction and figure it out in relationship to the sun and stuff, and he has to inherit that, by his genes, but then all of these other bees have to recognize that dance, and then they have to also be able to interpret that and go in the right direction. Now think about how, and they have to inherit that, but they aren't necessarily all related. So the deal is they have to inherit this from their parents, but he inherits it from his parents. This has got to be pre-planned even before they're born. Now that is irreducibly complex. I mean, just think about that. These bees do this instinctually, and they know exactly where to go, but they have to get that. Think about how many different proteins, how many different systems, probably, at least 20 or 30 different systems. And not only would one bee have to inherit it, but the other ones would all have to inherit the stuff to understand it and then use it. It's truly an amazing thing, and it certainly suggests that a designer did this. This is a complex behavior, very complex, and it's communication. Remember, we've talked about the fact that if you have information or something that try to communicates a message, that suggests design, not chance. Here's another example, the migratory habits of birds. Let me give you just one example here. There's a species of German warbler over in Germany, obviously, and actually they live other places besides that, but that's where most of them are found. Now, the parents, they leave Germany and they migrate to the headwaters of the Nile in Africa before the young can fly. Now, that's several hundred miles. I mean, maybe even 1,000 miles. I forget what it is, but it's a long ways. Then the young follow about 5 weeks later after they can fly, and they end up with their parents at exactly the same spot. Now, how does that happen? How do they accomplish this? They don't know where they're going. They're born, they hatch, they grow, and then they take off and they end up exactly where their moms and dads do. Now, this is a pretty amazing thing. The reason why they can do this is they have at least 3 different compasses at their disposal. They can look at the position of the sun in the sky, and that helps them to know where to go, where they're going. They also have the patterns of stars at night. So if it's cloudy during the day, but they can also fly at night, and they can look at the stars and figure out which direction they're going. And then the Earth has a magnetic field, and they have really sensitive sensors that can sense the magnetic field. So they have 3 different ways of actually navigating. You say, well, how did they know about this? Well, in some cases, they actually took some of these warblers and they put blindfolds on them. Okay. And they flew them. And if they had blindfolds so they couldn't see the sun or they couldn't see the stars at night, they couldn't find their way, by that. But what they could do is they could still end up where they were supposed to be, and they realized that they had these things that are sensitive to magnetic fields. So they navigate by the sun and stars if they're there. If it's cloudy, they use radical pair chemicals in their retinas, and these birds have them. There's a few other species that have them as well, and they sense very weak changes in the magnetic field. Now, remember, these birds they don't have a way. Their parents didn't talk about this. They don't know where those parents went. So this has to be pre-programmed into them in order to go where their parents are. Their parents don't teach them. They don't smell. They don't have sense or anything like that. They only navigate in those 3 ways. And this is all pre-programmed into them at birth. So how can this happen by chance? I mean, all these systems have to be in place for survival value at the same time. Not only do they have to be in the birds, the parents have to know where to go, but the kids have to know how to follow the parents, and yet they end up at the same place. Now, there's no way that this doesn't just scream design. I mean, this could not happen by chance, again, because it's so complex. Plus, it's actually pre-programmed before the animals are actually born. It's pre-programmed into them as they're developing as a juvenile, as an embryo. So this is truly an amazing thing, and it truly speaks for chance. Is it irreducible complexity? Yes, it is. And that demands a designer. We can't keep hiding behind some of this thing. Materialistic scientists say, well, it all happens just by chance. No, there are some things that demand a designer. In this case, we have all kinds of systems that have information in them. How in the world can you have information like that, especially pre-programmed before they're ever born? How can you say that happened by chance? We would say that this screams that there's an intelligent designer behind it all, and that designer has a pre-planned program for these birds so that they can find their parents when they need to.